But anyways, so with whatever it is that we're going to do for question 3, the one thing I can safely say is, wait, what about the marker location? It's on the African side. Like the marker location of this question. Is it on the African side?
For the
Location. Yeah, like how much each question is counting. Yeah. Oh, is it my network? That's like, yeah, I think my network today is like really bad. Like, damn it. Like, I don't know if it's the network here, but you were saying, like, I heard and then I didn't hear anymore. So it's like, I think
I
this
was saying
network
the
is
market
punishing
location.
one of us or something.
I
don't know what one of us
sent
did
the picture of the market. Hello.
Oh yeah, thanks. Thank you very much. Thank you. We are appreciated. Anyway, so I can see the questions now. So it says here, write down we have a quadratic number pattern. They want us to write out T4. Okay, so I'm assuming you got T4.
Yeah.
Or did you?
I did.
No, yes. Maybe. Okay, perfect.
Oh yes, I said
so
I
if you got T4, then it basically just, okay, what else T4?
T4 was negative 82. It was negative 82.
Yeah, what else T4?
Negative 82. Like minus 82.
T4 was negative 82. Okay. Negative 82. Perfect. Yeah. And was 3.2 okay?
3.2 was fine. I just struggled with 3.4.
Okay, perfect. So the big
and 3.3. Yeah.
Nice. We are love to or see it. 3.4. Oh yeah. Okay. So we are there then. We are there at 3.3 and 3.4. So the big idea with 3.3 says between which two terms of the quadratic number pattern will there be a difference of negative 121. So before we even carry on, right, the advantage that you have with using the gold book, so that I can see which papers they put in there this year, because the advantage that you have is reason. Maybe like, I don't know, maybe there's like load shedding, and I believe there's load shedding, how you can access the internet banking, right? You can always double check if a paper is like there on the second channel.
Oh, okay.
What you may call the metric maths past papers channel there, right? Luckily.
Yeah.
So with 3.3, the first method to the madness behind what we're gonna do. It says between which two terms of the quadratic number pattern will there be a difference of this much? So get your number pattern, right? You basically have like negative 145, and then you have negative 101, and then you have negative 82, right? So with what? Yeah, I can hear you. I don't know. Is it my network or let me? Maybe
Yeah,
disconnect absolutely
you were glitching.
everything from ZWP. Okay, so I disconnected the phone. Let me disconnect the laptop now. Yeah, so I disconnected everything from the Wi-Fi. Literally just this tablet is connected. Yeah, no, I
Okay,
can
thank
tell.
you.
I can tell. How about now? Am I still glitching?
Yeah, it's
Oh,
clearer.
I'm better. Am I
Yes.
still glitching?
No, you're fine.
Or am I still glitching? Oh, perfect, perfect. Good. Ah, snap, dude, this thing was muted. I'm saying I'm switching over to data, so give me 2 seconds.
Okay.
Ooh. I'm back, right?
Yeah, I can hear you.
And I'm not glitching anymore, right?
No.
Away. So anyways, to start off, what they're referring to here is the sequence of first differences, because your sequence of first differences will have, for example, what are these numbers here? What is negative 80, whatever? What is negative 82 minus negative 101?
Was it? I wrote this. Was it 19?
19. And then for this one, what is negative 101 minus negative 1?
It was 21.
21.
Yeah.
And then what is negative this minus 145?
It was 23.
23. So do
Yeah.
you see that in this sequence of first differences, your first term is 23, your second term is 21, your third term is 19, going on and on. Do you see that?
Yeah.
And do you also see that this sequence is decreasing?
Yes.
Yeah. So the big idea here is, if you read the question, right, between which two terms, let me cloak this out, between which two terms of the quadratic number pattern will there be a difference of negative 121? So if you look at your sequence here, right, just looking at it nicely, this is T1 and T2. Between T2 and T1, you have term 1 of this sequence. Do you see that?
Yes.
Yeah, so that's the analogy we should be thinking of. And then between T3 and T2, you basically have, and just color code this nicely. Between T3 and T2 here, you basically have term 2 of the sequence of first differences. And then between T4 and T3, you basically have T3 of the sequence of first differences. So somewhere here, we're going to have the number negative 121. We just have to figure out which two terms, if you subtract them, is giving us the negative 121. Because remember, there's going to be a number in the original sequence here. There's going to be a number in the original sequence here. So we don't know what T this is, and we don't know what T this is, you see. So it's going to be T something minus T something is going to give us this 121. That's what this question is asking us. Do you see that?
Okay. Yeah.
Yeah. So in this sequence here with in yellow, we just have to find out where will negative 121 be And then we just have to reverse engineer that question. You get?
Okay.
Yeah. So to start off here, this is going to be this is just a quadratic, this is just a arithmetic number.
Arithmetic.
Yeah, because it's just 23, 21, 19. Somewhere along the lines, there's 121. We don't know where it is. So here Tn is equal to A plus n minus 1g. Now we know that Tn is, no, we have to put a negative, the negative 121. Yeah, A is 23, n is what we're looking for. And then the common difference here, let's see, is just a negative 2.
-2. Yeah.
Yep. So you can work this out. What does this give us? Or rather, let me see here. Let me just work out what this gives us. Let's see there.
I'll finish all the other work.
No problema. Okay, I was just trying to get done with something. So what did you say you got?
73.
Okay, let's see. And then, oh no, what is this here now?
Minus 121, minus 25. Yeah.
So that's like 146. Okay, negative 73. No, wait, what?
But positive.
Oh no,
Yeah.
oh yeah, that's the positive.
Yeah.
Okay, so what we can see is that it is term number, what you may call.
73.
Yeah, term number 73 in this sequence of first differences. So if this is 73, you see that in the original one, it would be term number 73 here, and then term number 74 there. Yeah, because you see, just like here, term number 1 is between 2 and 1. Term number 2 is between 2 and 3. Term number 3 is between 3 and 4. So term number 73 will be between 73 and 74.
Oh, okay.
Yeah. So that's
that's
that's where the 4 marks will be coming from. So here you can then say, therefore, T4 minus T what? What did we say again? T74
74
minus T73 is equal to negative 121. So this will be good enough as your final answer.
Oh, okay. The memo at the back made it so confusing.
Hectic.
Yeah.
That's good. That's good. So let's see here. Let me just see here. Yeah, so we can move on then. Wait, what did I do here? Yeah, so we can move on to the next one. Copy this thing here, and then move on to 3.4, paste. So let me crop this out. There we are go. There we are go. So 3.4 says what must be the value of each term in the number pattern so that the value of the maximum term, wait, what value must be added to each term in the number pattern so that the value of the maximum term in the new number pattern will be a 1. Oh, well, I don't think this question is too difficult. Okay, let me not sound condescending. Oops, shouldn't have started off by saying that. That was so off. What the hell? Yeah, forget I said that. Forget I said that, you know, like, let's see. So it says here, we need to, wait, what? Yeah, so with all that's been said, right? Our sequence has a general term, right? Negative something, 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 something. Like negative n squared plus 26 minus 170. So I think with what I said, what I was maybe trying to highlight is that you won't have a hard time understanding what we're going to be doing. So yeah, I think we can put it like that so that everybody's happy. and yeah, so let's see here, paste. So with this question, right, this is our general term. The one thing we always need to be blunt about is that this is a quadratic number pattern.
Mm.
or that this is a quadratic, it's a parabola. You see, it's gonna be a frowning graph. It's gonna be a frowning graph where your turning point is like negative, what you may call negative. No, your y-intercept is gonna be negative 170. You see.
Mhm.
So with something like this, we already know that this parabola will obviously have a maximum value. You see,
Mhm.
max value. Now this parabola having a maximum value, we already know that this question now, what must be added to each term in the number pattern so that the value of the maximum term in the new number pattern is 1. So we can find out what is the original maximum value, and then from there we can just see what we can do to make it a 1. You get?
Yeah, I get it.
Yeah, because so far originally the maximum value is whatever this y value is there. We don't know. So this would be
Mhm.
whatever Tn is, you see? And then
Yeah.
this would be representing n, if I can put it that way. But anyways, let me not be too technical. Like let me even remove the Cartesian plane there because yeah, we don't have to be extra like that. So let's just get the maximum value here. The maximum value, we can get it by firstly getting the maximum n value first, or the n value that's going to produce the maximum, of which we can just use the turning point formula, you see, minus b over 2a. And then here b is going to be the 26 over there, a is the -1. So this is going to be 13, you see, of
Yeah.
which now we can throw 13 in there. It's going to give us 26, 13 there. And then what is 13 times 13? Well, we can just put all this in the calculator once actually, so
Yeah.
that we don't have to make silly mistakes or anything along those lines. Or
It's giving
so
me 25.
20,
5.
25. Okay, so the original turning point, I'm actually thinking to myself, why did we even get the original turning point? Like legit, I'm literally asking myself that question. So it's kind of weird why I'm asking myself that question now after we've done it. But then I think as a hunch, I mean, as long as we know the original one, we can see what we can do to get the new one. Because look, if the original one is somewhere at 25 there,
Mhm.
for it to be 1, we need to move this graph 24 units down.
Mm.
You see?
Oh.
Yeah, so if you're going to move the graph 24 units down, it means we're going to end up with a new equation. And then, yeah, that's going to be quite interesting. Or is it?
So do we just say 170 minus 25?
Yeah, technically. Yeah, definitely. That's literally all
Oh.
actually. Because what but the only thing I'm thinking now is if we have a new general term, then how does this answer the question? What value must be added to each term in the number pattern so that the value of the maximum term in the number pattern formed will be a positive 1. But let's see what the new general term is. We say the new general term will be, let's say here new. It'll be everything here minus 24. So it'll be like negative n squared plus 26n. And then we're gonna have here minus 24. And then the other thing is it's a 4-mark question. So I'm like, bro, are we like going the long dry here? Are we even doing something systematically? But I think what we're trying to showcase here is instead of spending time overthinking, we can go with something that we know is valid. You know, we're not like doing something randomly per se. So this is going to give us negative 194. So this would be the new equation, right? And I mean, one way or the other, I mean, look, I think this is all we need. Everything must just be what they say, which value must be added to each term. So each term must be added by negative 24. But then why does that not sound like it makes sense? But let's check something. Let's check
Let
something.
me check the memo.
What is no wait, hold on.
Okay.
What is the original term 13 from our equation? The original term 13 is 25.
5, yeah.
So what is T13 of the new equation? Let's just check that.
Okay.
And then negative 194. What do we get here?
313.
What? Say what? Dude,
Yeah.
are you joking?
No, I'm not.
Hi, 313.
Yeah, because I said 13 squared plus
You
26
mean
times
negative
13.
13 squared. The negative and then bracket squared.
Oh, I didn't put the negative. Okay.
Whew, whew, whoo-wee, whoo-wee, wee.
Sorry. Okay, it's negative 25.
Negative 25. How? But in this thing now, Patung. How, man? How? Negative 25, you say?
Yeah.
Okay, wait a minute, wait a minute. If we move the whole graph 24 downwards, then this whole thing here moves 24 downwards, then what? Nah, wait, hold on. Let me just double check something. Where's this thing? Give me 2 seconds. Give me 2 seconds.
Okay.
Thank you very much. Let's see here. 13 squared plus 26, 13 minus this. Yeah, I think for the first one, that's where the issue was. Because you see, for the first one there, it's negative 1. Here.
Mm-hmm. Oh.
Wee-wee.
13 plus 26.
But it's super chilled. So let's see. Negative 13 there squared plus 26.
Oh, it's negative 1. Where did we get 25
Yeah.
from?
Angazi, ma'am. I don't know me. I don't know. I don't know. I just hear the numbers and I write them. So if it was 20, if it was negative 21, it means that we need to alter this. You see, the highest value here was negative 1 based on this information, because this is giving us technically the x value of the turning point. This is like serving as the y value of the turning point. So if it was at negative 1 here, for it to become positive 1, we need to move it up by 2.
Upwards 2 point, yeah.
Yeah, you see, it needs to move up by 2 units. So if it moves up by 2 units, it means that the new equation here, we'll have to do plus 2 here. And then this here will be negative 168. And then we'll have a new value here. So let's see.
So do we have to write out the new equation that we get?
Yeah, we're just using it to almost like double check. Yeah, so if this is going to be the new equation, this new equation is going to produce a new highest value of 1. So clearly we're seeing that every term, because it says here what value must be added to each term. So each term must be added by 2, you know, because we here, this was just testing it out. This was just testing. You know, the bottom part here, we were just testing out what we got. Well, technically here we're testing out.
Oh,
You see,
okay.
because all we said was from negative 1 to 1, we have to move up by 2 units. So that's why the 2 units is our answer. But then what we then did here is to just test out if we do move everything by 2, does it make your new turning point a 1? And it does, because you see the 13 will still remain the same. You see, position number 13 will still be where we're getting the highest value, position number 13. So it was initially negative 1, but now it's going to be what you call positive 1.
Okay. Also, when they ask for like the minimum value, do we still use like the turning point formula to get that?
Say that again.
The minimum value, like in the question I did, they asked for the minimum value of like the quadratic, the quadratic sequence. So do we use the turning point formula? Because I used it and then I got the answer
Yeah.
right.
Yeah, definitely. And then later
Okay.
on, when you will learn differentiation, then you will be able to use differentiation.
Oh, okay. Okay, I think I'm good with this question. It wasn't too bad.
Most def.